Let us look at what a group is in group theory using a 12-hour clock. Okay, so here the hours is a set of 12 numbers 0 to 11. Of course, in the clock we also have minutes, a set of 60 numbers, and we also know that we have something called as AM and PM. So let's say 0 represents AM and 1 represents PM. So which means A is equal to the set of two numbers 0 and 1. Now we are going to focus only on the set H, which represents the hours in our clock. Now there are certain operations that can be performed, but primarily we are focused on addition. Now here it is not a normal kind of addition. So we will represent the plus symbol in a special way. So A addition modulo 12B is equal to C, where A and B belong to H, then C also belongs to H. What this basically means is that if you take any two elements in the set H, so let's say 3 and let's take 5. So 3 plus 5, 1, 2, 3, 4, 5 gives us 8, which is C. So C, if you notice, also belongs to the set H. Similarly, we can take any two numbers. Let's take 10 plus say 5. 1, 2, 3, 4, 5. So 3 also belongs to the set H. So A addition modulo 12 B is equal to C, where A and B belong to H, then C also belongs to H. This is called the closure property, or we also say that this set of numbers are closed under addition modulo 12. Now let's look at this. What do we have here? A addition modulo 12B and then addition modulo 12C. Here A addition modulo 12, addition modulo 12 of B and C, where A, B, C all belong to H. So the point is, you add these three numbers in any order, you will get the same result. This, I'm sure you know, is called the associative property. Now let's look at the next one. A addition modulo 12E is equal to E addition modulo 12A is equal to A. That means E is a number in the set itself, in H itself, such that if it is added to any other number in this set, gives that number itself. So is there such a number? Say if we take 3, if we add 4 to it, we get a different number. But if we take any number and if we add 0 to it, we get the number itself. So 4 plus 0 is 4. So here E is called the identity, and this property is called existence of identity. Now let's take A and let's take its inverse. If we add them together, what do we get? We get E, which is the identity. How do we figure out this? Given say 5, what is its inverse? So A is 5 and identity is 0. So what do we have to add to 5 to get 0? So 1, 2, 3, 4, 5, 6, 7. We have to add 7 to it to get 0. So 5 is the inverse of 7 and 7 is the inverse of 5. So let's start with 7. We add 1, 2, 3, 4, 5. We get 0, which is the identity. That is the existence of inverse. Now, the moment we are able to say that a set of elements is closed under an operation, is satisfying the associative property under that same operation, and there exists an identity and there exists an inverse for all the elements, then we call it as a group. In short, we represent H as a group. Within brackets, we write H comma addition modulo 12. This represents a group. And we can also say integer modulo 12 is equal to this group. So, do you notice any other groups in this? Yes. M is also a group of 60s numbers. That means integer modulo 60 is equal to within brackets M comma addition modulo 60. Similarly, A is also a group. We can say within brackets A comma addition modulo 2. Now just try to map for M and A all these axioms. Okay. Now, apart from this, we also have addition modulo 12b is equal to b addition modulo 12a. That means order of addition doesn't matter. Now, again, you know this. This is called the commutative property. Okay. So, in general, we call it as a additive group of integer modulo 12 because only addition is being treated as a operation of interest. This particular group is also called a cyclic abelian group. Now, why cyclic? Cyclic because there exists an element which can generate the entire group using repeated addition modulo 12 on itself. That is 1. So it is written within a bracket. And since it generates the entire group, we say equal to H. So here 1 is the generator of H. Abelian because H is commutative. We have already seen that. Since it is commutative, we call it as abelian group. Since it has a generator which can generate the entire group, it's called cyclic. Interesting, right? Again, let me remind you, there is a link to a PDF book which describes all these details. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.